Okay, now for yet another example of determination of volume about a given line. Okay, we have for the functions y is equal to 3x squared, y is equal to 0, and x is equal to 3. We're looking at determining the volume about the line x is equal to 3. So we have, again, with these functions, if we draw out what we have in this particular case, alright, we have y is equal to 3x squared, y is equal to 0, and we have also x is equal to 3, okay, upon which the solid is going to be revolving about. And so we have, in looking at the integration that is going to be involved, okay, so we're looking at revolving about x is equal to 3. Okay, we're going to be looking at integration over the variable y. So we have modifying the quadratic function and rewriting as a radical function along the lines of x equals. Okay, we have with a modification. Okay, we now have x is equal to the square root of y thirds. Okay, as x goes from 0 to 3, y goes from 0 to 27, and we have our key corner points, okay, for the figure. And again, we are looking at revolution about the line x is equal to 3. And now for what we have from a visual standpoint, okay, we have with integration about y, okay, the radius that is going to be involved. And let me, before I jump ahead, too far ahead, okay, we have the line of integration upon which the revolution is going to be done. Notice we have perpetual contact with x is equal to 3. There's no hollowing out or spacing, and since we have continuous contact with x is equal to 3 from start to finish, okay, we will be able to use the method of disks. And for the type of figure that is going to be formed, okay, again we have I guess almost like a bugle once again, and we can use the method of disks. And again, for the radius, again, that is going to be the width itself. And let me just state this, okay, say the width right minus the left, so you have 3 minus the square root of y thirds. And so we have, so for the formation, okay, we have for slicing it up in disks, okay, and for the apportioning of the disk, okay, again we have the radius is going to be equal to 3 minus the square root of y thirds. And now in terms of what we have in setting up the integration, okay, once again we're going from y is equal to 0 to y is equal to 27, and for what we have in the integral itself, okay, we have in the determination of the volume about the line x is equal to 3, okay, again we are integrating, okay, going from 0 to 27 up high, and the square of the radius we have to be that of 3 minus the square root of y thirds. And a little bit of tricky algebra is going to be involved. Okay, some of it goes back to the trigonometry courses that you might have had, especially working with radicals. And now we have for the square of this radius, just going ahead and drawing this on out, okay, just for 3 minus the square root of y thirds quantity squared. If you square out 3, you have 9. Square out the last term, okay, this will free up the radical. Square of a negative is positive. And then for the combination of the outside and inside terms, okay, you have minus 6 times the square root of y over the square root of 3. And if you were to piece together, now 6 over the square root of 3 is going to be 2 times the square root of 3 multiplied by the square root of y. Okay, we have gradually reducing. We have 9 minus 2 times the square root of 3y plus y thirds. And to set this up, this expression up, to make this more integration friendly, we can write at least the square root of y as an exponent. So we have for the square of the radius, we can express as 9 minus 2 times the square root of 3 times y to the 1/2 plus y thirds. And in looking at what we have in configuring, okay, just what the volume is going to be, okay, as we go back, okay, to the square of the radius, and again establishing, you have for the volume, you have going from 0 to 27, so you have pi times 9 minus 2 times the square root of 3 times y to the 1/2 plus y-thirds. And then in looking at applying the power rule of integration, okay, we have pi times the quantity of 9y minus, okay, and then you have 2/3 of y to the 3/2 times 2 times the square root of 3. We have our coefficient at minus 4 times the square root of 3 over 3 times y to the 3/2 plus y squared over 6 as y goes from 0 to 27. And as you plug in 27 for y, okay, quite a bit of computation that is going to be involved. And in fact, once you plug in 27, okay, 27 to the 3/2 times negative 4/3 to the square root of 3, this will end up as a whole number coefficient. And combining all the terms together, the exact value of the volume of the solid rotated about the line x is equal to 3 is going to come out to 81/2 pi.